Hello and welcome back to Maths with El Profelo. We just did a video finding all incongruent solutions for this congruence, 3x is equivalent to 6 mod 15. Went through that process to solve. Now we're going to do 16x is equivalent to 8 mod 28. Okay. For these problems, it is always important to double check what is your greatest common divisor, right? And the greatest common divisor of 16 and 28 is 4, right? And 4 does divide 8, so therefore solutions exist, right? So therefore our solutions exist, right? That the greatest common divisor of 16 and 28 does in fact divide 8. So I'm going to have 4 distinct solutions. Now, how can I solve this? Well, the Euclidean algorithm allows us to solve this whenever we don't have that one of our numbers is that greatest common divisor. So I'm going to figure out how to write 4 in terms of 28 and 16. Well, Euclidean algorithm will tell us that 28 is equal to 1 times 16 plus 12. All right? And 16 is equal to 1 times 12 plus 4. And 12 is equal to 3 times 4 plus 0. So this is our greatest common divisor. Now, working backwards, we know that 4 is equal to 16 minus 1 times 12. And that's going to be 16 minus 1 times 28 minus 1 times 16. All right, solving for 12, 28 minus 1 times 16. And if I use hippity hoppity, my distributive property, right, distribute this negative 1 to the 28 and to the negative 1 times 16, that's going to give me 2 times 16 minus 1 times 28. So therefore, I know that 16 times 2 plus 28 times negative 1 is equal to 4. Okay? Now, what does that tell me? Right? What does that tell me here? Right? That if I know that 16 times 2 plus 28 times negative 1 is equal to 4, what that tells me is that I have close to a solution to 16 times something is going to be equal to 8 mod 28. Okay? What does that mean? Right? Well, that means here that I can think about this as 16, right, times 2 is going to be equal to 4 plus 28 times 1. Okay? Well, what does that mean? That means that 16 times 2 on division by 28 has a remainder of 4. Okay? Well, what do I need to have a remainder of? I need to have a remainder of 8. I need to have a remainder of 8. Well, how can I make that happen? Well, I'm going to multiply everything in my equation. I'm going to multiply everything in my equation by 2. Right? Do to the left side, do to the right side. Well, what does that tell me? Well, this is going to give me 16 times 4 is equivalent to 8 plus 28 times 2. So in other words, 16 times 4, when I group into groups of 28, is going to have 8 left over. And I can always double check that. And I can say, okay, well, what is 16 times 4? 16 times 4 is 64. If I subtract 28, I have 36 left. Subtract 28 again, I have 8 left, and there is my remainder. Okay. So what does that mean? That means that I have an x naught equals to 4, because that is a particular solution for this, and I need to figure out this m divided by d. Well, that's going to be given by 28 divided by 4, which is 7. Okay. Now, how am I going to find all my solutions? I'm going to need to find, right, x naught plus m over d times n for n equals 0, 1, 2, all the way to d minus 1. So that means that my solutions are going to be x equals 4 is one solution, right? Then I'm going to have x equals, add 7, so that's 11. Add 7 again, that's 18. And add 7 one more time, right? And if I do that, that gives me 25. So my least positive incongruent solutions are given by, right, my least positive incongruent solutions are given by 4, 11, 18, and 25. Right? And I know that if I simply added 28 to each of these, or subtracted 28 from each of these, or really any multiple of 28, I would be getting to solutions as well. But fairly typically, you are going to be asked for the least positive incongruent solutions, and that would be 4, 11, 18, and 25. And once again, how did I do that? I used the Euclidean algorithm, set up the Euclidean algorithm, got to a solution, right? Then used the Euclidean algorithm to find the remainder that I needed, in this case 8, right? So the Euclidean algorithm got me to 16 times 4 is equal to 8, 16 times 2 is equal to 4 plus 28 times 1. Multiplied everything by 2, so that 4 would become an 8, right? And then I would have my particular solution of 4. Okay? We'll look at another example of this in our following video. Maths by el Profe Lo.